Hey there! Welcome to TechBiz Insight, where we use technology to solve real business problems and delight customers. If you're new, hit subscribe, share, and comment, so you don't miss how these tools boost results. 2 quick questions. What business problem are you solving today, and which database is helping you do it? Drop questions below. I'll answer now and again at the end to help you move faster. 3. Top database management systems. A good DBMS enforces simple, vital rules that protect your customers and your business. Like 1 unique email per account, no duplicates, less confusion, and no orders for out-of-stock products, fewer refunds, happier buyers. This ability to maintain data integrity builds trust, which drives repeat business. If your bank app showed the wrong balance even once, you'd leave. Accuracy keeps customers. A robust DBMS creates one source of truth, so every team, app, and customer sees the same facts, and it stays reliable under heavy use, launch days, sales, and peak traffic. In short, it's the bedrock of reliability and of great service. So, why should you care? Because understanding databases is like learning the grammar of digital business, so you can communicate value clearly, powerful, scalable, dependable. From a simple personal blog to a complex e-commerce empire, same principles, bigger impact. Choosing the right DBMS and using it well improves speed, accuracy, and customer experience. This guide will walk you through the most popular options and explain strengths and trade-offs in plain, business-first terms. All right. Let's get started. For decades, one model set the standard for trustworthy data. The relational model, simple tables that made business records consistent and clear. Proposed in 1970, it brought order to messy information and raised service quality. Data in tables, easy to understand, easy to share across teams. Tables have rows. Each row is a customer, an order, or a product. Columns, details like price or address. Think spreadsheet, organized info that powers decisions. Each row is one record, one real-world thing you serve, like a product in your catalog. Each column is an attribute, like name or price, or address, for smooth delivery and support. The relational part links tables, so you see the full customer journey. One table for customers, another for orders. Connect them to know who bought what and how to serve them better. This structure turned chaos into clarity, a foundation for great operations. The language for this world is SQL, the way you ask business questions of your data. Structured query language. It's the universal tongue of relational data used everywhere. With SQL, you do 4 essentials: CRUD, everyday business actions; create, add a new customer or order; read, look up exactly what you need; update, fix mistakes fast; delete, remove what no longer belongs. Example, add a new row when a shopper signs up, or retrieve VIP customers for a targeted campaign. Update their address to reduce failed deliveries, or remove stale test data to keep reports clean. Say you want to email New York customers. Select name from customers. Where city, New York. SQL turns business questions into precise answers, fast. That power and clarity explain why relational databases remain so popular. Another key, a schema, a clear blueprint for your data. It defines structure up front, so teams work in sync and apps behave. Which tables exist, which columns they have, and what types of data are allowed. Text, numbers, dates, clean, consistent entries every time. It may feel strict, but that's how you improve data quality and reporting. The schema prevents costly errors, like names in phone fields or broken invoices. That rigidity is a feature, critical in finance and compliance, and in research and regulated industries where accuracy is everything. Table-based systems also excel at transactions, the heart of business flows. A transaction groups steps so they succeed together, no half-done orders. Classic example, a bank transfer. Debit one account, credit another. Never double charge or lose funds. If any step fails, roll back, customers stay protected. That's ACID, rules that keep transactions safe. Atomicity, done completely or not at all. Consistency, data stays valid. Isolation, parallel checkouts don't collide. Durability, once confirmed, it sticks. Net result, safe, reliable payments and orders. That's why relational DBs are the go-to when failure isn't an option. Among many relational options, two matter a lot for the web and apps you use daily. MySQL, one of the most popular, widely used databases, especially across web development, fast pages, dependable logins. It's open source, free to use, modify, and distribute, lower costs, faster starts. That accessibility fueled adoption. Teams could build and learn quickly. It became the M in LAMP, powering a huge slice of the internet. Linux, Apache, MySQL, PHP, Python, Perl. MySQL is easy to set up, fast for common reads, and backed by a massive community. Answers when you need them. In practice, it's a reliable, battle-tested workhorse. It powers the backends of countless sites and services you use daily. It excels at structured content like user profiles, blog posts, product catalogs, and forum threads. Content that must load fast. Because it's so common, there's a wealth of documentation, tutorials, and third-party tools, so teams ship sooner. Great for developers starting out and for lean teams moving fast. Popular CMSs use MySQL by default. WordPress, Joomla, and Drupal, millions of sites rely on it. Translation, content loads, dashboards report, customers stay engaged. It's the dependable engine behind a big slice of the internet. Picture an e-commerce shop selling handmade crafts. A products table stores items, so pages show exactly what's for sale, name, description, price, and quantity in stock, preventing oversells. A customers table holds accounts, names, and shipping addresses, ensuring smooth delivery. When someone buys, the orders table records the purchase, linking customer ID to product ID, clean, traceable sales. The model keeps inventory accurate, orders trackable, and customer data consistent, fueling better service and insights. This is MySQL's bread and butter, and why it's everywhere. It shines in red-heavy scenarios, very fast at fetching content for users, perfect for sites with many readers and fewer writers. For a blog or a news site, speed keeps audiences engaged. Thousands read for everyone who comments. MySQL handles that pattern well. Its simplicity and speed made it the default for many small and mid-sized web apps, a champion of practical results in the database world. If MySQL is the popular, easy-to-use sedan, Postgres is the feature-packed wagon built for demanding trips. Like MySQL, it's free and open source. But Postgres is known for rich features, deep extensibility, and tight standards, helping teams deliver complex, correct outcomes. It was built with integrity and correctness first, ideal for serious workloads. That's why developers pick it for complex applications that need advanced capabilities and rock-solid reliability under load. It's often chosen beyond simple content storage. Think analytics and heavy reporting. Strong at complex queries, data warehousing, and geospatial analysis. Real-world maps and routes. Built-in geographic support means location-aware features with less custom code, like find all coffee shops within 5 miles. Great for users on the go. It also supports sophisticated data types and custom functions, so logic lives closer to the data. That flexibility can simplify apps and boost performance. Do complex work directly in the database. Less data movement, faster results. Often more efficient than pulling everything into your app. Real-world example, a financial analytics platform. It stores vast transactions with certainty, ensuring no data is lost or miscalculated. Postgres handles trades, balances, and market data, keeping everything consistent. ACID guarantees help every financial step complete safely. Then teams run complex queries for reports and insights, spot trading patterns, and measure risk. Fast, accurate decisions. That mix of power and integrity makes Postgres ideal for mission-critical systems. No surprise its popularity has surged recently. Many developers now default to Postgres over MySQL for advanced needs. Thanks to robust features and long-term stability and a steady stream of improvements, like strong JSON support for flexible modern apps, giving you NoSQL-like flexibility with relational safety. If you want relational structure plus extensibility, Postgres is a compelling, future-proof choice. 4. Choosing the right database system. New project? Start with the business outcome, then pick the database. Ask, what service are we delivering? Payments, bookings, feeds, or analytics? Core fork. SQL for transactional trust and consistency. NoSQL for agility and scale. Tie the choice to SLAs, uptime targets, and regulatory needs. Also consider capacity growth, ops effort, and cost per request. Choose SQL if you need ACID transactions, strong integrity, and a strict schema. Typical SQL services: payments, orders, inventory, bookings. Decision rule: trust first. Money moves or balances shown. Go SQL. SQL excels at referential integrity, joins, and audit-friendly analytics. Service lens: prevent oversells, guarantee seat locks, reconcile payouts. Operations lens: meet 99.9% plus SLA with transactions and rollbacks. Compliance lens: predictable schema, access controls, clear audit trails. Choose NoSQL if you need rapid iteration, evolving schemas, and high write throughput. Typical NoSQL services: personalized feeds, events, catalogs with variants. Scale lens: horizontal sharding and commodity nodes to meet spikes. Cost lens: pay by throughput and storage. Optimize hot versus cold data. Quick SQL checklist: money flows, inventory must be exact, joins, BI, audits, 99.9% plus uptime. Quick NoSQL checklist: evolving data, per user feeds, event streams, massive writes, easy scaling. Hybrid rule: SQL for source of truth, NoSQL for feeds, cache, and search. When in doubt, protect trust. Start with relational. Add NoSQL where agility or scale demands it. Goal first, service second, database third. Pick for integrity, reliability, analytics, agility, and cost. 5. Future of database systems. Databases are evolving to improve services, not just store data. The goal: faster time to service, fewer outages, smarter operations. Cloud-managed databases lead the way. Spin up in minutes, auto-scale, and let the platform handle patching and backups. Think Amazon RDS, Cloud SQL, and Azure Database. Automated maintenance with built-in high availability. Less ops toil means teams ship features sooner and focus on customer value. SRE-friendly tooling, monitoring, alerts, and point-in-time restore keeps dashboards green and incidents brief. The business impact: quicker launches, fewer outages, predictable costs, and apps customers trust. Next, distributed or new SQL systems scale trustworthy transactions globally with low latency, plus built-in analytics and AI enable smarter recommendations and faster support. Choose tech that reduces customer friction and accelerates outcomes. 6. Conclusion. Technology's purpose is solving problems, delivering service, and growing business. Databases are the backbone. Choose by data shape, consistency needs, scale, and team skills. The right fit drives reliability, happy customers, and growth. MySQL, simple and fast for the web. PostgreSQL, features and rigor. Oracle and SQL Server, enterprise muscle. MongoDB, flexible documents and scale. Different paths, one goal, trusted data that powers outcomes. Keep it simple, start small, and practice on real use cases. Pick one stack and ship. The best database is the one your team can operate confidently. Stay curious, keep learning, and ship. Comment your top business problem. I'll suggest a database path. I'm replying now and after this video. Subscribe, share with your team, and let's build wins.